This is question 2 of the AQA Physics Unit 1 June 2014 paper. In this question, you will be assessed on using good English, organising information clearly and using specialist terms where appropriate, which this is a 6-mark question. And I must admit, I think this is a very nice 6-mark question, because it's about particle theory, which is quite straightforward. So the information in the box is about the properties of solids and gases. It tells you that solids have a fixed shape and are difficult to compress, which means to squash, whereas gases will spread and fill the entire container, and they are easy to compress or squash. That's the bit that some people missed out, I feel, when answering this question. It says, use your knowledge of kinetic theory to explain the information given in the box, and you should consider those 3 things there. Number 1, the idea that the spacing between the particles. Number 2, the movement of the individual particles. And then number 3, which is point blue again, the forces between the particles. So to get all 6 marks in this question, you must comment on all those 3 things for solids and gases. So the kinetic theory is a key part of this question. And just to recap really, that the kinetic theory states that everything is made of particles and that the particles are free to move around. And we'll be using this as we want to explain the rest of the question. So let's look at the solid parts of this question first. And what we're expected to do in this part of the question is explain why solids have a fixed shape and are difficult to compress. And explain those 2 things, we should consider the spacing between the particles, the movement of the individual particles, and the forces between the particles. Now when I answer questions like this, I find it easier to have a picture in my head, and hopefully your picture in your head of solids looks similar to the one that I've just highlighted over on this side of the screen over here. So the idea that you've got these particles that are all close together. In this case they're actually touching, as they should be, and that's because they've got strong forces between them. Now you don't see solids where the particles go into each other, and the reason for that is that the forces between the particles will become repulsive for very short distances. But the thing that we're going to explain in terms of why they have a fixed shape is that they're all very close together, they're all touching, and they're all regimented, and they've got strong forces holding them in that position, which gives them the fixed shape. So you can see that I've sort of talked about spacing, and I've talked about forces there. Now to explain why they move, or their movement, is that the solid particles aren't free to move about, they're only free to vibrate. And you can see that these annotations here are showing that those particles in that solid there are vibrating. To explain why they're difficult to compress, what you would do there is you'd explain that the solids have a very fixed shape, they're all very close together, and therefore it's very difficult to push them further together. Now I just want to highlight to you the things that you should really be including when you talk about this. The idea here is you can see that the solids have got particles that are close together, which we've already discussed. There's no room for particles to move closer, so very hard for them to compress. It's very hard for you to compress them. The idea then that they vibrate about a fixed point, that's their movement. You can see that we've got a strong force of attraction at a distance. The forces become repulsive if the particles get close together, and particles strongly held together, not free to move around, so the shape is fixed. And that bit that I was just showing you there, guys, this bit that I'm highlighting in red now, that comes from the mark scheme as points to include, or points that could be included for solids. It's not expected in your answer that you include all of these points. Now the final part of the question, we're going to look at gases. Remember that what I expect to explain here is that gases will spread and fill the entire container, and they're easy to compress or squash. In doing this, we should consider the spacing between the particles, the movement of the individual particles, and the forces between the particles. Now, as before, I think it's easier to try and think of answering these problems, these questions, with an idea of a model in your head, and hopefully you'd agree that your model of gases would look something similar to that shown in the top right hand corner over there that I've just circled in blue. And you can see that the gases have got large spaces between them, the particles are free to move around and they've got high energy, they move a lot faster than solids, and the reason for that is there's very few forces or no forces of attraction between the particles, they're just free to move and do their own thing. You can see that in here you've got vast amounts of free space, which means that the particles could be squashed. We can move the walls into the container and squish the particles close together because there's actually space for them to come closer together. The particles are free to move around and they can go in any direction they want to, which is one of the reasons why they'll spread out to fill the container. And again, That's because the force of attraction between the particles is negligible. It doesn't come into play. They're not held together in any way. They're free to move apart, and therefore they can spread out to fill the entire container. Now, I've just dragged up, I'll highlight in red the mark scheme, or the points that you could include. Again, it's not expected you to have every point here, but you should have a point from the space between the particles, the movement of the particles, and the forces between the particles. So you can see here, the first one is that the idea that they're far apart. There's space between them so you can compress them. They move randomly. There's no force or negligible force of attraction, and they can spread out in all directions to fill the container. And if you include an equal number, at least sort of 3 areas to cover those of that one, and 3 areas to cover the points to consider for solids, then you should have got yourself a very high mark on this question.